Hello, my name is Miss Muse, and we are reviewing today how to apply factoring to word problems. My favorite student is Austin Calvert Fields, and she is really stupid.
All right, thanks for that wonderful introduction. On problem number 1, they say the area of a rectangle is 10y squared plus 3y minus 4, and they want us to find the length and the width, and they also want us to find the perimeter of the rectangle. So, we are going to start off by writing the area formula for a rectangle, which is length times width. And they tell us the area is 10y squared plus 3y minus 4. Well, the length and the width are actually factors. And they're factors because the length and the width multiply to give you the area. So we are going to take the total area that they give us, the formula in the problem, and then we are going to factor it to find our length and width. So I'm going to start by using the reverse box method. And I put my 10y squared up in the top, left-hand box, and I put the negative 4 down in the bottom. And then I multiply the coefficients 10 and negative 4 to give me negative 40. Now I have to list the factors of negative 40. And the factors I want to add up to positive 3 because 3 is the middle term. So my middle term is positive, so the larger number of my factors needs to be positive. So I'm going to write negative 1 and 40. Oh, I'm sorry, the larger number gets the smaller number should get the negative. I'm sorry, the smaller number should get the negative. And then there's negative 2 and 20. There's negative 4 and 10. And the last one I'm going to write off to the side is negative 5 and 8. So we know now that I'm going to put negative 5x, or sorry, y, because we're dealing with the variable y. So negative 5y and 8y. Now we have to pull out the GCF. So I'm going to find the GCF of negative 5y and negative 4. Well, the GCF there is just 1. That's the only thing that goes into both. That goes into both negative 5y and negative 4. And we know that the 1 needs a negative in front of it because the negative, and like I said, again, the negative goes in front of the 1 because the box closest to that number is negative, so it has to have a negative. Now I'm going to find the GCF of 10y squared and 8y, and what I pull out there is going to be a 2y. Because 2 is the largest number that goes into 8 and 10, and then they both have a y. I pull out the GCF of 10y squared and negative y, and that's going to be 5y. And then the GCF of 8y and negative 4 is going to be 4, and it gets a positive in front of it because the box closest to that number is positive. So the sign is positive in front of the 4. Now, that tells me that my factors, my area, can be factored into 2y minus 1 times 5y plus 4. And if we recognize that these two things are multiplying together to give us the area, we know that this is our length and width. So we've now found the length and width of our rectangle, which are 2y minus 1 and 5y plus 4, and they ask us to find the perimeter. So the perimeter of a rectangle, the formula is, someone tell me, 2L plus 2W. And now I just plug in to that formula. The length is 2y minus 1, and the width is 5y plus 4. And I distribute the 2. So that gives me 4y minus 2 plus 10y plus 8. And can anyone tell me what the next step is going to be? What do I need to do with my terms? Combine like terms, right? So when I combine the 4y and the 10y, that gives me 14y, and then the negative 2 plus 8 is positive 6. So my perimeter is 14y plus 6. Okay, before we move on to problem number 2, we have a shout out.
What Miss Muse said about chi earlier is completely false and is not correct. So you shouldn't believe anything that Miss Muse says. And Sergio, I just want to tell you I love you, and I'm going to take you to McDonald's.
All right, problem number 2. The area of a rectangle is 4a squared minus 9, and they want us to find the length and width and draw and label a diagram, and then find the perimeter. So it's the same concept. They give us an area. Area equals 4a squared minus 9, and we need to factor it because we want to find the length and the width. And area equals length times width. So in order to factor this, we need to think about the methods that we have. And you should be able to look at this problem and recognize something. Does anyone recognize anything about this problem that's special?
It's a perfect square.
Right. They are both perfect squares. So, and there's a subtraction sign between the two, so it is a difference of perfect squares. And the way we're going to do this is we get to go ahead and figure out what our first and second bases are going to be. Remember, we just set up our parentheses. And 4a squared can be written as 2a times 2a. And 9 can be written as 3 times 3. So that is what makes those two things perfect squares. And there's a subtraction sign in between them. So our first base is 2a. So we put that at the front of both of our parentheses. Our second base is 3, so we put that at the back of both parentheses. And when we're doing a difference of perfect squares, we do a plus and a minus. So that is now our area factored. And this is our length, and this is our width. So now we need to find the perimeter, or we can actually go ahead and draw our diagram. So I'm going to just draw a rectangle with 2a minus 3 and 2a plus 3 to represent the diagram. Now they're asking us to find the perimeter. Well, we know that perimeter equals 2 times the length plus 2 times the width. Well, we just plug in what we had found in the previous steps of our problem. The length was 2a minus 3 plus 2 times the width. The width was 2a plus 3. And then we need to distribute the 2, so we get 4a minus 6 plus 4a plus 6. The last step to this problem is that we need to combine like terms. So I have a 4a and a 4a, which gives me 8a, and then the negative 6 and the positive 6 are a 0 pair, so those cancel out. So our perimeter of this rectangle is 8a. This problem is going to be the same type of problem in number 3. They give us the area of a rectangle, and they ask us what the length and the width of the rectangle are and what's the perimeter. So we start off writing our area as always. The area is 5b squared minus 9bd minus 2d squared. Now, the difference in this problem and the ones we've worked before is that we're dealing with 2 variables, and we have 2 squared terms. But we're still going to approach it in the same way. We're still going to factor it to find our length and our width. So I'm going to draw a box and do the reverse box method this time. And I still put my first term in the upper left-hand corner, 5b squared. And I still put the last term, negative 2d squared, down at the bottom right-hand corner. I still put my circle, and I need to multiply the coefficients. So 5 times negative 2 is negative 10. So I put negative 10, and then I factor it. So when I factor this, I need to have the larger numbers of the 2 factors should get a negative because they need to add up to a negative number, which is negative 9, our middle term. So I'm going to put 1 and negative 10, 2 and negative 5, and that's all we have, and we have to figure out which of those add up to negative 9, and that's 1 and negative 10. So this is where the biggest difference in this problem comes. We are going to put negative 10 BD in this box and 1 BD in the other box. And the reason we're doing that, if you notice back at the problem number 1 that we did, the middle term was y in our trinomial. The middle term was y. So what did we put in those boxes that we filled in with the factors? We put y. Well, here our middle term has BD in it. So in these empty boxes, we're going to put BD. It's the same concept. Now we pull out our GCFs. The GCF of negative 10BD and negative 2D squared is going to be negative 2D. And I pulled out a 2 because that's the largest number that goes into 2 and 10. And I pulled out a negative because the box closest to that little spot is a negative 10. So that has a negative number in it. And then they both had a D as a variable. Now, the negative 2D squared did not have a B, so we don't get to pull a B out. Now I pull out the GCF of 5B squared and 1BD, and that is B. B is the only thing that I can pull out from those two boxes to get that. So now I have to find the GCF of 5B squared and negative 10BD, and that's going to be 5B. And then the GCF of BD and negative 2D squared is positive D. So my factors of the area are B minus 2D times 5B plus D, and that is the length and width of my rectangle. And then they're asking us to find the perimeter again in this problem. So once again, our perimeter formula is equals 2L plus 2W, 2 times the length plus 2 times the width. I plug in my length of B minus 2D plus 2 times my width, which is 5B plus D. I distribute the 2, and I get 2B minus 4D plus 10B plus 2D. When I combine like terms, my final perimeter of this problem ends up being 12D plus 12B, I'm sorry, not 12D. Minus 2D. And that is the final answer to this problem. Okay, well, once again, I rewrote D when I meant to write B. Okay, so let's move on to problem number. So problem number 4 gives us the area of a rectangle, and they tell us it's 4x squared plus 8x plus 3. And the area is length times width. Once again, we're going to do reverse box method. In the upper left-hand corner, we put 4x squared. In the lower right-hand corner, we put 3. And then we multiply 4 times 3, and we get 12. Well, the factors of 12 and that need to add up to 8, so we do 1 and 12, 2 and 6, 3 and 4. And the ones that add up to 8 are 2 and 6, so we put 2x and 6x. And then we pull out our GCF. So the GCF of 2x and 3 is 1. The GCF of 4x squared and 6x is 2x. And the 1 has a positive because it's the box closest to it is positive. The GCF of 4x squared and 2x is 2x. And then the GCF of 6x and 3 is 3. Now, that tells me my factors are 2x plus 1 and 2x plus 3. So this is my length and width. And this time, instead of asking us about the perimeter, they want to know the difference between the length and the width. So what I do now is I subtract my length and my width. So I'm going to do 2x plus 1 minus 2x plus 3. And when we subtract this negative is distributed and changes the signs inside of the parentheses. So it makes it the opposite. So it's 2x plus 1 minus 2x minus 3. And then I combine like terms. This positive 2x and negative 2x cancel out. And then 1 minus 3 gives you a negative 2. So this tells me that whenever we subtract the length from the width, it gives us a difference of negative 2. But really, the difference between lengths is never really negative. That just tells me that the length is smaller than the width. So the difference is actually going to be positive 2. So the difference is actually positive 2 between the lengths. The difference between the width and the length is 2. We don't have to worry about the negative.
I just want to say that Miss Muse is the best teacher that's ever lived, ever.
And Austin is my favorite student.
Yes.
No, Austin just tends to like to say that. Paula is so hurt. So now in these next problems, what they're going to ask us to do is find the area of the shaded regions. So if you notice in this first problem, we have a rectangle, and then on the outside we have 2 half circles. And when you put those half circles together, it'll be a whole circle. So if we find the area of the rectangle, and then we find the area of that one total circle and add those together, then we'll have the area of the shaded region. So we know the area of a rectangle is length times width. They give us the length of 4r. 4r is our length of our rectangle. The width of the rectangle is unknown. So if we notice, the width of the rectangle is actually the diameter of our circle. That's the longest length of the circle. So right here, this side that I'm shading in darker is the diameter of the circle and width of the rectangle. And does anyone know the relationship between the radius of a circle and the diameter of a circle? What is it, Valerie?
Wait, I can't remember, but I know one of them is
Radius is half of the diameter.
So if the radius is half the diameter, the diameter is 2. The radius is 2 times, or the diameter is 2 times the radius. So the width of our rectangle is 2r, if that makes sense. The length is 4r and the width is 2r, since it's the diameter of the circle. It's 2 times the radius. So the width of our rectangle is 2 times the radius. This now becomes 8r squared. So the area of our rectangle in this problem is 8r squared. And now we have to find the area of our circle so we can add them together. And the formula for area of a circle is pi r squared. And they tell us the length of the radius is r, so we don't even have to change the variable r in this problem. So we're going to add those two things together. The area of the rectangle, 8r squared, plus the area of the circle, pi r squared. And when we do that, we can factor this out. This is the total area of that shape. What can we pull out of this that they both have in common? They have an r squared, correct? So we pull out the greatest common factor of r squared, and we're left with what on the inside? 8 plus pi. So this is the area of the shaded region, r squared times 8 plus pi. In problem number 6, we need to find the area of the shaded region that's left. So we're going to find the area of this square and subtract the area of the circle. And that'll be, what will be left is the area of the shaded region. So if I draw a radius, I can draw a radius at any point in the circle, from the center to the edge of the circle. And they tell us the radius is length r in this problem. Well, I can also draw another radius the other direction, and that will also have a length of r. So we realize that the side length of the square is 2 times r. And since we know the side length of the square, we can find its area. because the area of a square is side squared. Okay, so I replaced the side length with 2r, so it's the quantity of 2r squared, which equals 4r squared, because 2 squared is 4, and then r squared is r squared. So we found the area of our square. Now we need to find the area of the circle. So area is pi r squared. And since we already have our radius as length r, we're good to go, and we don't have to do anything else. We have the area of the square and the circle, and now we need to just subtract the two to find the area of the shaded region. So I take the area of the square, 4r squared, minus pi r squared, the area of the circle. And then I pull out anything they have in common, and the thing they have in common is r squared. That's the GCF, and I'm left with 4 minus pi. And that is the area of my shaded region. All right, in problem 7, once again, we're finding the area of the shaded region, and we're going to find the area of the larger rectangle and subtract the area of the smaller rectangle. So the area of the larger rectangle is going to be length times width, and the length is 4x, and the width is 3x plus 1. I distribute the 4x, and I end up with 12x squared plus 4x. So that is the area of my larger rectangle. Now I need to find the area of the smaller circle or rectangle. So it's length times width, and that's going to be x squared minus 3x times 6. And so I can distribute the 6, and I get 6x squared minus 18x. So once again, I'm going to subtract the area of the smaller circle from, or rectangle, smaller rectangle from the larger one. So 12x squared plus 4x minus 6x squared minus 18x. And because of this subtraction sign, I have to distribute. So I'm going to distribute the negative all the way through. When I distribute the negative, I end up with 12x squared plus 4x minus 6x squared plus 18x. And now when I combine like terms, 12x squared minus 6x squared leaves me with 6x squared. And then I have a 4x and an 18x. And when I add those together, I end up with 22x. Now, what I can pull out of here, what they both have in common, I can pull out 2 because 2 goes in evenly to 6 and 22. And then I can also pull out an x because one has an x squared and one has an x. So what I'm left with, 6 divided by 2 is 3. And then x squared divided by x is x. So I'm left with a 3x plus 11 because 22x divided by 2x is just 11. And that is the area of the shaded region for that problem. The last problem is very similar. We're finding the area of the shaded region, but this time we have a circle with 2 smaller squares inside of it. So area of a circle is pi r squared. We're going to find that first. The radius in this problem is 2x. So I replaced the r with a 2x. The radius in the problem was 2x, and I replaced it. That's all I've done so far. And when I square 2x, it becomes pi times 4x squared. And by convention, we always normally write the number out front. So I'm just going to rearrange the order of everything and put 4 pi x squared. It's the same thing, you just put the number out front. And that's just kind of a normal math rule. It doesn't matter. When you're multiplying, the order does not matter. Now we have to find the area of the 2 smaller squares. And the area of a square is side length squared. The side length here is x. So we just put x squared.